Hi, welcome to my video on proving triangles congruent. Proving triangles congruent. And recall that we can prove triangles congruent by SSS congruency, SAS congruency, ASA, AAS, and also an HL. So notice the S stands for sides, the A stands for angle, and in this one here, hypotenuse leg of a right triangle. And you cannot prove them congruent by AAA, that gives us similar triangles, or you cannot prove them by ASS, angle side side. Remember, we always say in math, don't make an ass of yourself, or don't make a donkey, in the sense of the animal. Okay, let's do some examples of proofs proving triangles congruent. We have angle, this triangle, AB intersects FC. B is the midpoint of FC. If B is the midpoint, that means that BF equals BC. AF equals AC, given. And as a result, we want the triangles congruent. We have a common side here. AB is equal to AB, common side. So the triangles are congruent by SSS. So let's write, since I have the proof done in my head, now let's write it up. B is the midpoint of FC, given. And if B is the midpoint, that means BF equals BC, definition of a midpoint, because the midpoint is in the middle. And number 3, AF equals AC, that's a given. Now sometimes some teachers will allow you to put all the givens in the first step and then you can take it from there, but I did it one at a time because I wanted to take the midpoint and show you that these two segments are equal. And now we have AB equals AB, which is this side, and that's, we call it reflexive, or I call it the common side to the two triangles. So that means the triangles ABF is congruent to triangle ABC, and the reason is SSS congruency. Three sides of one triangle are congruent to, or equal to three sides of another, then the triangles are congruent. And to illustrate that, I made up the figure, and I took the diagram, and I took a pair of scissors, and I took the diagram that I have up here. Notice this has gone up a bit. Let me straighten it out. There's the diagram. So look at it closely. So that diagram right here, this diagram, is this one. I took the scissors and cut them in two and marked A on each of the angles and B. So the two triangles are congruent. If I lift them up and bring it back and fold them on top of each other like this, then you can see that the two triangles are congruent because they fall exactly on each other. Notice that AB is common to both sides of the triangle. Let me show you that again. I take it away to pick it up. So there's AB, A is equal to A, B is equal to B, so AB goes with AB. Just wanted to show you that congruency. Now let's have a look at B. We have a quadrilateral diagonal. WX is perpendicular to XY, and VY is perpendicular to YX, and we have XV equal to YW, so they're equal. So we have an angle side, we need another angle on another side. And we notice that XY is common to the two triangles. And notice now when we do that, we have an ASS, angle, side, side. And we can't use that. So because we have perpendiculars, we have to say that we have a right triangle. So number one is that WX is perpendicular to XY. And we have VY perpendicular to YS, and that's a given. And as a result of that given, that means that let's call this angle 1 and angle 2. Angle 1 and angle 2 are right angles. And that's definition of perpendicular lines or segments. We could say lines or segments. And as a result of being right angles, that means that the triangle XYW and the triangle YXV are right triangles. Definition of right triangles. They're right triangles because we have right angles. And as a result, now we have XV equal to YW given. That's one pair of sides. And that's the legs of a right triangle. Now we have XY equal to YX. And that's because of the common side. And as a result, we have a pair of right triangles. So now we can say the triangle XYW is congruent to the triangle YXV. And we have right triangles with, that's the hypotenuse, that's the leg. So that's called the HL. Congruency. Hypotenuse legs of right triangles. But notice I had to state that I have a pair of right triangles in order to use the HL, because if I don't, I'll have an ASS, and I can't use that. And just to remind you, notice that AB is equal to AB, because the A falls on the A, and the B falls on the B. But here, the XY is not XY, XY is YX, because this angle here at 1 is this angle here at 2. So notice XY is YX. And C, let's do this proof. We have parallel lines, so PQ is parallel to RT. And we have BR bisects QT. So PR bisects QT. So that means that that's WQ equal WT by bisector. So we have a pair of sides equal. We need a pair of angles. So I could go with this angle right here, which is P equals R. I could say that this angle here, Q, is equal to T. Because of the parallel lines, the alternate interior angles are equal. And these are alternate interior angles equal. So I have the triangles congruent by AAS. So I have the proof laid out, so let's write it up. PQ is parallel to RT, and that's a given. As a result of that given, I have angle P equals angle R, angle Q equals angle T, and that's called the parallel line theorem, and their course alternate interior angles equal. So if two parallel lines are cut by a transversal PR, alternate interior angles. If two parallel lines are cut by a transversal, these alternate interior angles are equal. So I need a side, so we have PR bisects QT. 1, 2, that's a given. So as a result, I got WQ equals WT, and that's the definition of segment bisector. And as a result, we have angle size. So the triangle PWQ is congruent to triangle RWT, and the reason is an AAS, angle side congruency. I could have also stated that this angle right here and this one, PWQ and RWT, are equal by vertically opposite angles, and I could have had an AAS going this way, or I could have had an ASA. If I named those two and these two, then I could have an ASA. But I used both angles dealing with the parallel lines. D. Okay, another proof. I have AB equals CB, AB equals CB, pair of sides. HB bisects angle ABC, HB bisects angle ABC, so that means angle 1 is going to equal angle 2. I'm naming them with a number because it's easier to say 1 and 2, because I got to say A, B, H, C, B, H, so I'd rather put 1 and 2 in. Then ask your teacher, can you do that? It makes it easier to see. And I have a side and an angle. Oh, I see a common side here. Notice these two angles are equal, so therefore BH is going to be BH. Not like up here. Remember, these were the equal angles, so I had to go X, Y, Y, X. But because 1 equals 2, then B and each triangle goes with each other. So the triangles are going to be congruent by SAS. So here we go. I got the proof laid out. Number 1, AB is equal to CB, given. Number 2, HB bisects angle ABC, and that's also a given. I could put the two of them in one, I only had one. And now I have angle 1 equals angle 2. Definition of angle bisector. And BH equals BH. That's a common side. Common side of each triangle. Notice BH is in both triangles. So we have this side, we have this angle, and we have this side. So the triangle ABH is congruent to triangle CBH, and it's a side angle side. Side angle side congruency. Okay, let's see, try some more. Now I have a bit for practice, and practice means, if you wish, you may pause your video and work each of these out. When you get it done, press playback to see if you got it right. Here we go, practice. BA bisects angle FAC. BA bisects FAC. So that makes these two angles equal. Again, I'm going to name them with 1 and 2. Makes, instead of going FAB and CAB, which you could, I put a 1 and a 2 here. So these two angles are going to be equal. AB is perpendicular to, there's a perpendicular there, so that means the right angle at B on each side. So ABC and ABF are perpendicular. I had to prove the triangles congruent. So let's see. I have no sides so far, so I have to go AB is equal to AB, the common side. So that means I have to go with ASA. I have to say, make these two angles equal. So I'm going to put a 3 here and a 4 here. So because these are perpendicular, these angles are going to be equal because they're right angles. Two lines forming, two perpendicular lines form congruent adjacent angles. So here we go. BA bisects angle FAC, given. Angle 1 equals angle 2. Definition of angle bisector. You bisect an angle, you get two equal angles. Number 3, AB is perpendicular to FC, given. That means if perpendicular, we could say that angle 3 and angle 4 are right angles. Definition of perpendicular segments or lines. And angle 3 equals angle 4 because all right angles are equal. I did that in a previous proof. And now we have 3 is equal to 4, 2 strokes. So I have these two angles equal right here. I have these two angles equal. So I got the two angles equal. So I have to get the side. So AB equals AB. It's a common side to two triangles. AB is in both triangles. And as a result, I have angle, side, angle. ABF is congruent. Triangle ABF is congruent to triangle ABC. And the reason is ASA congruency. Notice I didn't do the proof in the order of an ASA. This is the angle, this is the angle, and this is the side. But when you look in the diagram, it's an ASA. Some teachers might want you to do the proof as I want the angle, then the side, and then the angle in that order. But I don't have this order, but I do have it in the proof. So check with your teacher. Number 2, I have a diagram. AB and HI bisect each other. Prove that triangles are congruent. Okay, so HM, notice the triangles. I got HM going with IM. HM goes with IM. That makes sense. And I got MA going with MB. So I got bisectors. So if they bisect each other, that means that MA equals MB, MH equals MI, because they bisect. I'm going to put, I got two sides equal. Two sides in the triangles are equal. And I need a third side or an angle, but the angle has to be in between. I can't have H. I can't have angle H because it's a ASS. Can't have A because it's an ASS. So I either have AH is equal to IB and get SSS, or I get angle 1 equals angle 2, and makes sense. 1 is equal to 2 by vertically opposite. So the triangles are congruent by SAS. So here we go. AB and HI bisect each other, given. And that means that MH equals MI and MA equals MB. So they bisect each other, so this segment equals this one, and this one equals this one. And that's the definition of segment bisector. So we have two angles equal, two sides equal. Now I need either, as I said, I got the angles, so angle 1 is equal to angle 2. That's V, make that a V, VOAT, or VAT. V vertically, make that a V, V vertically opposite angle theorem, or vertical angle theorem. And now we have the triangles HMA congruent to triangle IMB, and it's in, notice, side angle side. Side angle side congruency. Okay, number 3. Let's see, we have a diagram, a diagonal. So this is quadrilateral. So it says that XY is parallel to VW. So I mark that. And then it says that XW, so I'll mark this with 2 arrows, is parallel to VY. So these sides are parallel. These sides are parallel. And how do I get triangles congruent? So I need parallel lines. Remember we said before, parallel lines gives us equal angles. So because these lines are parallel, then angle 1 is going to equal angle 2. Alternate Z, alternate interior angles. Because these 2 lines are parallel, then this angle is going to equal to this one by alternate interior. So I have 2 angles. So I got to get a side. Oh, this side, WY equals YW, because it's a common side. So the triangles are going to be congruent by angle, side, angle. So let's do the proof. Now I'm going to do one parallel line at a time. I could do the 2 of them into one, but I'm doing the 2 of them separate to show you. So if XY is parallel to VW, then angle 1 equals angle 2. That's PLT, alternate interior angles equal. Number 3, we have XW parallel to VY. That's a given. And as a result, we got angle 3 equals angle 4. PLT, alternate interior angles equal. Notice I could have put the 2 of these into one and wrote down, I could have only had 2 statements, but I did this pair of parallel lines to show you got these angles. Then I did this pair of parallel lines to show you got these angles. That's why I did them separate, so you can see them. There's a 4 there. 5. Then I got YW equals WY, common side to 2 triangles. And again, notice that 1 goes with 2, so the Y goes with the W. 3 is equal to 4, so the W goes with the Y. So it's not YW, YW, it's YW is equal to WY. Again, check with your teacher on that. And that means I have angle, 2 angles on the side. So XYW is congruent to VWY by ASA congruency. Angle, side, angle. And we have one more proof to do. Let's see about this proof. We got to look at the diagram. We got X is the midpoint of EC. X is the midpoint of EC. If X is the midpoint, then that means XE equals, excuse me, XE equals XC. We got angle H is equal to angle B, so I'll mark that with 1 stroke. They're equal. And I'm given that AB, which is this side, line, or segment, is parallel to HC. So there they are. So I'll put the arrows on it. So they're parallel. So how do I get the triangles congruent? I want triangle EXA, this triangle congruent to this triangle, CXB. So you notice that EX goes with CE. Notice that XA goes with XB. And notice that EA goes with CB. Okay, but I have a pair of sides. I notice that I have these 2 angles equal by VOAT, so I got a pair of sides equal and a pair of angles. So either I'm going to equal, can't get any more sides. I need another angle. So why did they give me the parallel lines? Parallel lines gives me a pair of angles equal. So I got H is equal to B. So if I could only get, I got a connection with the parallel lines. Parallel lines gives me a pair of angles equal. I got H is equal to B. So if I could, these are parallel lines, so angle 1 is going to equal angle H, corresponding angles equal. So if H is equal to B and 1 is equal to H, that means 1 is equal to B transitive. So now I have these pair of angles, these pair of angles, and the sides. So now that's how I'm going to do my proof. So X is the midpoint of EC given. Number 2, XE equals XC, definition of midpoint. Angle 3 equals angle 4, VOAT, or again VAT, vertically opposite angle theorem. If two lines intersect, then the vertically opposite angles are equal. Now we got to get if angle H equals angle B. That's a given. Now we have to get, let's use our parallel lines. AB is parallel to HC, given. The parallel lines gives us angle 1 equals angle H. And notice that's a PLT, and 1 and H are corresponding angles equal. And as a result, if H equals B and 1 equals H, then angle 1 is equal to angle B by transitive property. Transitive property. So again, H is equal to B, 1 is equal to H. H is here twice, right here and here. So B is equal to 1, transitive. Property of equality. Now I have these two angles equal. 3 is equal to 4. These sides are equal. So now I have triangle EXA congruent to triangle CXB, and it's an AAS. AAS congruency. So that brings us to the end of proving triangles congruent by all the different ways. And remember, triangles are congruent by SSS, SAS, ASA, AAS, and HL. But they're not congruent by 3 angles equal AAA or ASS. And if you like my video, click on the like button, the subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you. Bye-bye.